In the beginning, they say that there is a geometric sequence. Whenever we're talking geometric sequence, you should remember we are talking about the same ratio between terms. That means every time we multiply the same number. If we use some space to represent the term, we know that every time we are going to times the same value, the same ratio. So basically, if the first one is called A1, then next one we'll call A1 times R. And then A1 times R square, AR power 3, something like that. So that's the pattern of a geometric sequence. In this case, they're talking about A1, that means the first one is 64. While the fourth one, 1, 2, 3, 4, this is 343. If we think about times R, that means the first one, we times R for 3 times, it gives us 343. So if you understand the logic, you may directly write down 64 times R power 3 times will give you 343 here. So afterward, we just need to solve this equation. R power 3 is equal to 343 divided by 64. I don't want power 3, that's why I take the cubic roots. Then we may use calculator. We get 7 over 4, or we directly write down 1.75 is okay. This is one of the methods if you know what to do here. But however, if you want to rely on formula, it's totally fine. Just make sure you memorize those formula. And then for GS, geometric sequence, we are talking about the certain term. So the end term is this one. So you may write down, if we start again, you may write down T1. That means A1 here, in this case, is 64. While T4 is equal to 343. Afterward, you express this one in terms of A. So we know that A is equal to 64. At the same time, A power 3 gives you 343. Afterward, you try to solve the simultaneous equation, and you know that dividing is easier for us to handle. So this is equation 1, equation 2. We divide it. We consider equation 2 dividing equation 1. Then we will have AR power 3 divided by A in left hand side. Also, we have 343 divided by 64 in right hand side. A cancel out, power 3 is this item. The rest are exactly the same. So, but anyway, I think this one is more convenient if you understand the flow of a geometric sequence. Also apply to a metric sequence. In short, that means we already conclude the first term is 64 given directly and R is 1.75 times. We are going to solve this condition, and then we are trying to find the greatest n fulfilling this requirement. So we must start from the question, the 2n term, and then minus the n term will smaller than this target. So based on our equation here, this is AR power of 2n minus 1. This is AR power of n minus 1. Then we substitute the value 64, 1.75 power of 2n minus 1. This is 64 also. 1.75 power of n minus 1. I think the 64 is too troublesome, so I divide both sides by 64. Divide both sides by positive value will not trigger the change of the direction, so it's still the same. We get 1562.5 here. Now the problem is 2n minus 1 and n is not very systematic. I prefer power of 2n and power of n. So I think another method is both sides do the same thing. I try to both sides times 1.75. Again, both sides times the same positive value. We will not trigger the change here, so I don't need to change direction here. We get 1.75 power of 2n, that's our target, minus 1.75 power of n. It's give 2734.375. Afterward, I should realize that this is quadratic expressions. Because the power of ratio is 2 to 1 to 0, that means without 1.75. So therefore, I try to put everything to left hand side. 1.75 half to n minus 1.75 half n, and then minus 2734.375. Smaller than 0. Create one part equal to 0. And I better rewrite this one to be something power of 2. So I rewrite this one as 1.75 power of n power of 2. I can rewrite in this way. So it's obviously we are talking about something power of 2 minus something and then minus this one. It's no difference from the inequality that x squared minus 1 time of x minus 2734.375 smaller than 0. We think in this way. To solve this one, we should describe the function of this expression. We know that this is upward sloping. It's because the coefficient of x squared is positive. So it should be upward sloping. And then we are considering the boundary here, which are above the ground. So we are searching for these two roots. When we consider this expression equal to 0, that means we want to get the boundary. Then we get x is equal to 52.79 something, and then another root is x is equal to negative 51.79 something. So in this situation, we are searching the range to make this curve below the ground, because we say we want the target range is smaller than 0. So our target range is this region. We are going to write down the name of this region is x within the two boundaries. The upper bound is 52.79 something, and then the lower bound is negative 51.79 something. Or we directly write down 1.75 power of n, which is meaning x is between these two boundaries. Afterward, now we have to think how we can draw n from the exponent. We learn about 1/2 is the logarithm. Basically, we just considering these two parts. So we write down since 1.75 power of n less than 52.79. The reason I do not consider the lower bound is because log a negative number is not defined. So to avoid any troublesome in presenting the idea, so we just focus in this part. And then if we take log on both sides, one property of the log is a larger number will give a larger index. So that's why we can take log on both sides for inequalities. And also we don't need to change the direction. So we have n times of log 1.75 is smaller than log 52.79. Afterward, we are going to divide both sides by this item, but think carefully or check carefully whether this one is larger than 0. If this is negative, then it's trigger a change in the direction. This time this is positive value, so we can directly move it. Both sides divided by log 1.75, and we don't need to change direction. We get n is more than 7.0877 something, which means that the greatest value of n is 7. 7 still fulfill this requirement, while 8 do not fulfill the requirement anymore.